So now before we go to the next slide, I just want to highlight that if a property like the C here depends on more than just one variable, like the C here depends on time and spatial coordinates, we actually use these curved symbols, the curved D's, which stand for partial derivative. Okay, this is just to illustrate what I just said. Okay, so let's go to the next slide, and it's about Taylor expansion series. And this actually explains quite a bit, this Taylor expansion series. They explain where the finite differences come from and also where the truncation error comes from. Okay, so this is now what Taylor worked out. So think about you have a function f and it changes in the x direction. It's shown here in a little curve here. So you know what the value of your function is at the location x. Okay? Now you want to know what is the value of your function at delta x away. Okay, you just say a step of delta x 1 meter to the right. What is the functional value there? Taylor worked out that you can express this in terms of a series. Okay? So what you do is you can predict or work out the value of your function at x plus delta x, which is the value at your location x plus a correction, a series of corrections. The first one takes into the account for the slope of your function and the step delta x. You can see here is the slope and the delta x. The next higher order correction takes into account for the curvature, okay? And it has delta x squared in it. And then the third term, it's not the third term, it's the fourth term actually here in this case, has the third derivative, which is the slope of the curvature. And you have the third power of delta x, and so on. Okay? And this symbol here, this O, means you get the next term would be of the order of delta x to the power of 4 plus, but it's an infinite number of terms that you need to get the correct answer. What you also can do, instead of moving a plus delta x to the right, you can also just move to the left minus delta x. And then what happens in the Taylor expansion series is that just sum of the signs change. It's the signs change of these terms, which are the even number terms. It's the second one and the fourth one and the fifth one. And this is what we call Taylor expansion series. This is how finite differences are derived. And let's have a closer look at the possibilities that you